session. I just want to turn the transcription off. It can become quite annoying. Okay, so just one more time before we get started, please can you confirm that you can see the screen, the writing on the screen? Just squiggling a bit so you can see that. Okay, perfect. All right, so we can go ahead and get started. So, once again, good evening to everyone. I hope you're doing well. Welcome to another live session. Today, we are looking at Learning Unit 4 and covering an example of the questions, the typical questions that come off this learning unit. So, naturally, you've submitted your assignment one. I am almost done with marking actually. So you should hopefully get your results sometime soon. Maybe I'm assuming not end of this week because it's a public holiday. And I guess the operation teams will obviously not be working over the weekend. So I'm assuming maybe sometime early next week you should get your results. So the results have been quite good. Well done to you all. You can assess your feedback once you have received your results. You can go on to ARC and have a look at your assignment and check the feedback on the assignment and so on. But obviously, if you have any questions, you can let me know if you can't see your feedback or you can't see the assignment and so on. All right, so we are starting with Learning Unit 4 today. We should be done with this worksheet today as well. It's quite an easy section, one of the easier ones for the module. It is one that you can score quite well in. This is one of the compulsory sections in both your assignment 2 as well as your exam. So it's quite nice that it is an easy section because then it obviously makes it easy to do well in this section in your assignment 2 and your exam. It is possibly something you might have come across before. Again, it is quite relatable to real world because you will see that we're working with two variables in this learning unit and we're trying to assess the relationship between these two variables. So it could be quite relatable to work for some of you. And it is, as I said, one of the compulsory sections. So in your assignment two, you'll see that this will form part of section A generally, which is the Learning Unit 4 and Learning Unit 5 content, and then the optional one is Learning Unit 3. So let's get started with this. So this learning unit is called Linear Regression and Correlation Analysis. So the heading actually splits the learning unit into two equal halves. It's literally linear regression as your first half of the learning unit, and then correlation analysis is your second half. But the questions that you'll see on this worksheet are just combined, so you're not really going to see that separation, but I will point out to you in the questions which ones are the linear regression type questions and which ones are the correlation analysis type questions. So, what is the learning unit about? Again, naturally, you will have to look at your slides for a lot more detail than I will give to you here because I am focusing on the calculations, which is what your assignments are about. But just to give you an idea of what we're looking at here, it is a situation where we have two variables. Now, so far, since we looked at Learning Unit 3, we had dealt with just one variable, sorry, at a time. So, for example, maybe you were looking at a question that said to you, this is the age of 10 people in a store, dot, dot, dot. So you just had one variable, which was the age of the 10 people, and that was it. Now, here we're looking at two variables at a time, and we are trying to assess, firstly, is there a relationship that exists between these two variables? And then we try and put an equation to that relationship. And this is linear regression. So The first half of this learning unit, which is your linear regression, is where we try to determine, is there a relationship that exists between the two variables we're working with? And if there is a relationship, we want to know what kind of relationship it is. And we put an equation to the relationship. Correlation analysis, on the other hand, is where we look at the strength of the relationship between your two variables. So you'll see here we look at, is it a strong relationship? Is it a weak relationship? And we also look at, is it a positive or is it a negative relationship? So this is how the learning unit is split up. Essentially, all in all, it's about two variables and assessing, is there a relationship? What kind of relationship? What's the equation of the relationship? And then whether it's a positive, negative, weak, or strong relationship. And that pretty much sums up what your linear regression and correlation analysis is about. So again, you can have a look at your slides. It has a lot more detail if you would need any information over and above what I've just explained. But again, if you look at this page, this worksheet that I'm going through, this is a question from a previous year. Again, either assignment or an exam or a test that was written in the full-time space, which is what I like to do because it gives you an idea of what to expect in your assessments. So I like to work with something that has already been tested because it shows you the IIE methods of testing. So this question is from one of the previous assessments and it shows you the typical type of questions that you could get on this learning unit. So if you look at the question, and let's get started with the questions, it says to you here that the following table indicates the ages of a sample of female employees of People Plus Pty Limited and the corresponding monthly income of each of the employees. So the first variable we're dealing with here is the age of these female employees. So that's variable one. And the second is their monthly income. So that's the second variable. And you will see that as well in the table. If you look at the table, they have the two columns with the heading age in years and then the monthly income. Now, what's important to note here is that between the two variables, there is one that is always called the independent variable, and then the other is called the dependent variable. Now, how do we know what is what? So the dependent variable is called the y variable. And literal to the word dependent, it means that it is dependent on the value of the other variable. So in this case, it's dependent on the other variable, which is called the x variable. So you have two variables, x and y. One is called the dependent, one is called the independent. The dependent variable will depend on the x variable or the independent variable, but it's a one-way relationship, meaning that y depends on x, but x does not depend on y. So the relationship doesn't work in both directions. It's literally just a one-way relationship in this case where the y dependent is the y variable is dependent on x, but it is not vice versa. So in our question here, they've already told you which is your x variable, that is the age, and the y variable is your monthly income, which basically means in this case that the monthly income depends on the person's age. So sometimes they might not actually tell you what your x variable and your y variable is, meaning they would give you a question, and let's just say that they'd give you the same headings that you see in the table here, but they didn't give you x and y in brackets. So they just give you the two variables, but you would then have to identify which is x and which is y. So here, and I'm just going to give you a random example here. So this is built up on in your slides. If you have a look at your slides, you would see that there are more examples that can get you more familiar with these, so you are easily able to identify which is X, which is Y. But I'm just going to work with one other one apart from the one that we're working with in this example. So this is two variables, advertising and sales. So if we were given these two variables, but they didn't say to us that this is X and this is Y, we'd need to identify it. So the easiest way to identify it is just ask yourself, does advertising depend on sales, or does sales depend on advertising? And the idea is that the more we advertise, the higher the sales will be, or it should be that way at the very least. So your advertising then is going to be your X variable, or rather let's start with Y, since that's a dependent variable. We're going to say that sales depends on the advertising. So since sales is the dependent variable, that would be Y, and advertising then would automatically be the X variable. So always ask yourself the question of, does this depend on that? Does your advertising depend on your sales, or does your sales depend on your advertising? And it's the same with any variables that you have, any two variables that you have. Look at them and ask yourself that question, and this is how you'll identify which is X and which is Y. So now that we have that out the way, let's look at our question again. So they've listed out for you all of these X variables and all of these Y variables. And what's important to note here before we move on is that there are 6 sets of values that were given to you. So immediately that says to us, and I'm going to write it at the top here, that N is equal to 6. Remember, N is generally your sample size. So we know that N is 6. Let's look at what the question asked. So it said calculate the following, and it says by completing the table given below and then applying the relevant formula, determine the linear regression function for this bivariate data set. Now, the linear regression function, remember that is what the first part of the learning unit is about. This is where we are calculating, you'll see the formula, and this is literally what the linear regression formula is. It's y is equal to a plus bx. So it's also something that you might have come across before called the equation of a straight line. So with this, and again, please make sure that even though you might know your own versions of these, please don't use anything other than the one that is being taught to you in the session, because the IIE memos have it according to this. This is what your textbook has. This is how your module guide information will look. This is what your slides show. So it needs to be according to this. Please don't use your own methods to calculate any of these. Stick to the ones that are taught here. So the linear equation, the linear regression equation, or also called your linear regression function, is y is equal to a plus bx. And we need to basically put this formula together. Now, how do we put it together? So in the formula, y and x always stay as is when we calculate this equation. What we are actually calculating is the value of b and the value of a. So how do we calculate them? Now, there are specific formulas that are used to calculate these. All of them are in the formula sheet. So for your exam, you don't need to know these formulas. They will be included in the formula sheet. And then obviously your assignment 2 is open book, so you can just refer to your slides or your textbooks and so on. So how do we calculate the values of A and B and then put them into the equation? So when we calculate the values of A and B, the value of B is always calculated first. So let's show that. This is always done first and then the value of A. And then we put all of it into the equation. So what I've shown you here is that this is a sequence in which you would put together your linear regression function or linear regression equation, the value of B calculated first, then the value of A, and then the value of your, or put together your regression equation. Now, in order to calculate the values of A and B, we have to do what they asked us to do first. They said by completing the given table below. So we need to first complete this table and then we're going to calculate the values of A and B. Now, in this table, I'm just going to extend this one that's here. And you will need to redraw this generally in your assignment or your exam. We're going to have the columns X and Y first, and these are repetitive of what information is given at the top. So if you go to the top, oh, sorry. If you go to the top of the screen, X and Y, which were provided to you, you're literally just rewriting them. That is literally all you're doing here, just rewriting those values. So if we go to this table now, which is the one that you will, sorry, I'm just writing randomly all over the screen. Okay, so we're just literally going to copy those values. So I'm just going to rewrite them. X is 40, 49, and then I'm just going to continue with it below that. So 32, 27, 38, and 46. And then we'll just copy Y. So that's 43, 49, 36, 31, 41, and 42. Now we're going to add on 3 additional columns. So if you look at this, the table that they had given to you in this question, which is this one that was drawn up here, this is what they asked you to complete. However, sometimes, and you'll see at the end here, I've added on one more column, but you don't need to do this all of the time. This is only if they ask you to calculate, you'll see later on, a correlation coefficient. So you will just draw up what they asked you to include, meaning they actually only asked you to show x, y, x squared, xy. I'm just including this additional one at the end here because I need to show you how to calculate another value. So for your typical questions in an assignment or your exam, if they say to you include or copy the table below and redraw it in your answer booklet and complete the table, please copy it exactly as you see, meaning with the same headings they've given you. Don't add on anything that's not necessary. If you want in pencil, you can do what I'm doing here and add on the y squared column. But for the actual answer, you would only need to show what they have asked you to include here. Okay, so if you look at the columns that they've asked you to include here, this is x squared, xy, and then I'll do the last one, which is y squared. Okay, so let's just do what they have asked us to do for now, then I'll show you the last one. Okay, so here x squared, what does this mean? It means you're literally just squaring all of the x values in the first column. So 42 squared, 49 squared, 32 squared, and so on. You obviously don't need to show those square signs. I'm just showing that to you. So here 40 squared is 1,600, 49 squared is 2,401, 32 squared is 1,024, 27 squared is 729, 38 squared 1,444, and 46 squared is 2,116. Then you have your XY column. So your XY column is literal to what you see. It's your X variable multiplied by your y variable. So you're literally just saying then that it's x times y, first column multiplied by the second column. So 40 times 43, 49 times 49, 32 times 36, 27 times 31, 38 times 41, and 46 times 42. So again, you don't need to show any signs that I showed there. You'll just show your you'll just show your answers. So the first one is 1720, 2401, 1152, 837, 1558, and the last one is 1932. Okay, so if your question had asked you to complete the table below, then that's where you would stop with the actual columns. And then once you're done, you will need to sum up each column. So here you would then continue with this, continue with that, that, and that. And then you're going to add on one additional. Sorry, I just want to make that more straight. Okay, so remember last week when we worked with your learning unit 3, we said that this symbol means the sum of. So you need to show that because you're not going to say the sum of that entire column. So this is going to be the sum of, this column is your x values, so the sum of x. Then this column is all of your y values, so it's a sum of y. This column is all of your x squared values, so it's a sum of x squared. And this column is xy, so it's a sum of xy. And then you're literally just adding up all of the values in that column. So here, when you add up all of these values in the first column, the 40 plus the 49 plus the 32, 27, 38, and 46, that would give you a total of 232. Then when you add up the next column, 43, 49, 36, 31, 41, and 42, this would give you 242. Then the next column, 1, 6 plus 2401, 1024, 729, 1444, and 2116. That's 9,314. And the last column added up is 9,600. And that would literally be it. If you were asked to copy the table below and complete it, this would be the point at which you'd be done with the table. Now, as I said, because you do need the last column that I'm about to show you, a lot of the time, I'm just going to include it here, even though they didn't ask you to include it. So this is a column called y squared. And essentially, it's the same thing as x squared. The only difference is you're just squaring the values in the y column now. So 43 squared, 49 squared, 36 squared, 31 squared, and so on. Again, you don't need to show those squared signs like I did. So 43 squared is 1849. 49 squared is 2401. 36 squared is 1296. 31 squared is 961. 41 squared 1681. And 42 squared is 1764. And then again, you can add that up. So the sum of y squared now is 9,952. So that is your starting point. Before doing any calculations, you are generally required. So you're not always asked to draw up the table. You might not be asked to draw it up, but 99.99999% of the time, you are asked to draw up the table, complete it, and then get started with your calculations. So once you've drawn up this table, sorry, before we move on, can I just ask that you are all okay? You're on the same page, you're good, still comfortable? Okay, perfect. So let's continue. Sorry, just want to grab a sip of water and we'll continue. All right. So, as I was saying, once we're done with the calculations, we can now, sorry, once we're done with the table, yes, correct, Laura, you don't need to show any calculations. So, you're just going to show the totals and the figures like we showed it here. Okay, so now we can calculate the value of B because remember that is our starting point. We would need to show B first, then calculate A, and then put it into our equation. So what is the formula for B? Now again, this is in your formula sheet. So B is calculated as n multiplied by the sum of xy minus the sum of x times the sum of y, and then it's over n multiplied by the sum of x squared minus the sum of x, which is then squared. Now, although it might look quite intimidating, it actually isn't because we've calculated all the sums in the table, which is why that table is so useful because once you have the values squared already, summed up already, then you're literally just substituting into the formula. So these sum of x, sum of y, sum of x squared, and so on, it's literally just the totals that we had calculated in that last row in the table. So now let's substitute into this formula. So it says n, and what I would suggest is, even though the formula doesn't have brackets in it, I'm just going to show you how you will group them so that when you enter this onto your calculators, it's easy to identify how you would use the brackets on your calculators. So please use brackets as I've indicated here. If you look at the first part, it says n multiplied by the sum of xy, and that's in its own set of brackets. So this is because when you write it out and also when you put it onto your calculators, you're not going to have a problem because now you've grouped everything accordingly. So it's n, which we identified was 6, multiplied by the sum of xy. And here is the XY column. The sum of it is 9,600. So 6 multiplied by 9,600, and you're done with the first part. And then it says minus the sum of x. So here's the column x, and there's the sum at the bottom. So that's 232 as the first part of that bracket, multiplied by the sum of y. So here's the y column, and there's the sum of y, 242. And that's the first part of the formula done. That's your numerator done. So remember, there's no signs between the variables, which indicate that it's naturally multiplication. As long as there's no signs between variables, it's a given that it's multiplication. Then in your denominator, you have n multiplied by again. So in brackets, 6 multiplied by. Now it's the sum of x squared. So this column is x squared, and the sum of that column is 9314. So x squared is, or the sum of x squared is 9314. And then it says minus, and then it has the sum of x in brackets, and the sum of x is again here at the bottom, 232, and that is squared. So now you have everything that goes into your calculation of B. And if you put that onto your calculators, you'll get an answer of 0.71. So this is B done and dusted. Please be aware though that B can also be a negative number. It doesn't have to be a positive number. It's not restricted to being a positive number. So if you do end up with something that's negative, please don't be alarmed. It is completely normal. Okay, so that's the value of B, which is step one, then done. And then we now need to calculate the value of A. Now you'll see why A is done second. When we look at the formula of A, it says the sum of y minus b times the sum of x over n. So you see that we would have needed to have done b first because it's used in the formula of A. So we need the value of b for the formula of A, so this is why b has to be calculated first. So it says the sum of y, which is the second column here, 242 minus, and now again use brackets here. So put the b times x, the sum of x, into brackets. So it would be 0.71 multiplied by the sum of x is in the first column, 232. Sorry, just want to take out some of the writing there and the circle so that you can see clearly. Okay, so the sum of x is the 232, and now we can multiply that by the value of b, and then it's over n, which we said already is 6. So this gives us 12.88 on your calculators as the value of A. And now for the last step, we're able to take both the value of A and B and substitute it into our equation. So we said y and x stay as is in the formula, and then it's A plus B, x. So A we just calculated is 12.88, and then B was a positive, so it's plus 0.71x. All right, so that is your first question done and dusted. They asked you to complete the table below and then apply the relevant formula and determine the linear regression function. So you completed the table, you then calculated the value of B, you calculated the value of A, and then you substituted that into your equation, and you now have your linear regression equation or function, which is y is equal to 12.88 plus the 0.71 x. Okay, any questions before we move on? Okay, perfect. So let's look at the next question then. So the next question says, if a female employee is 39 years of age, estimate her monthly income. So, first things first here, we need to look at what the 39 years of age represents in the formula and the monthly income as well. So, remember from the table at the top, age is your x variable. So, I'm going to write here, this would be x, and to estimate her monthly income is the y variable. So basically, they're saying if we change the age to 39, what happens to the monthly income? So all you have to do here is take the formula that we already put together now, the 12.88 plus the 0.71x, and change the x variable, make it 39, and let's see what that gives us as the y variable. Or you can even do it within brackets, within the one bracket. So you can say times 39. Remember, 0.71x actually means 0.71 times x. So again, as long as there's no symbols between the variables, it's given that it's multiplication. So now when we calculate this, the y variable, which is the annual income, this will be a value of 40.57. Now, again, and I just want to point out something here. If you go back to the monthly income and you look at within brackets next to it, it is showing you monthly income is in hundreds of, sorry, it's in thousands of rands. So basically, what 43 means here is that it's 43,000, 49,000, 36,000, 31,000, 41, and 42,000. So they just simply left out the zeros because it becomes quite difficult to work with so many zeros. The numbers become too large, especially when you're multiplying them. They become very large and they become quite cumbersome to work with as such large numbers with so many zeros. So we leave out the zeros, but they just indicate to you in brackets that it is in thousands of rands. So in this question now, we calculated that it's 40.57, but we do need to show that the 40.57 is in thousands of rands. So we need to show, and I'll show you how to do this. We need to show that the 40.57 is in thousands of rands. So we simply multiply it by 1,000. You don't need to show this, where, like I'm showing here, times 1,000. I'm just showing it to you so you know what to do. You multiply that, and that will say to you that in thousands of rands, it's 40,570. So, to answer the question, and you will need to answer the question, which said if a female employee is 39 years of age, estimate her monthly income, you will say that the estimated monthly income is, and you'll say it is the 40,570. Okay, so just make sure that you do incorporate the fact that they mentioned to you that this was in thousands of rands. If it wasn't in thousands of rands and it was a normal variable, like let's just say like a random figure like kilometers, for example, then you don't need to multiply it by 1,000 because your answer would just be as is. But only in a situation like this where it was a monthly income. It was a thousands of rand figure, but they just left out the zeros. When you estimate and you forecast in a question like this, you will need to convert it to thousands so that you can interpret correctly. All right, so that is the second question. Any questions on that one? Okay, so I'm assuming all is good then. Let's look at the next one. So the next one is called Pearson's coefficient of correlation. So we're asked to calculate Pearson's coefficient of correlation and to interpret your answer. So how do we do this? Now, the two questions we've done so far, those were both based on linear regression. The two questions we're going to look at now are both based on correlation analysis. Now we're going to calculate what Pearson's coefficient of correlation is, and then we're also going to interpret the answer. But I just want to tell you in terms of interpreting. So I'm just going to write it at the top here because I have some space. So when we calculate Pearson's coefficient of correlation, firstly, it's telling us, remember, anything correlation related, a correlation analysis, tells us the strength of the relationship between two variables. So when we calculate this, it's denoted by the letter R, meaning that when you calculate the coefficient of correlation, you'll say R is equal to dot, dot, dot. Now, when we calculate R, we can get anything between -1 and a +1. So I'm just going to write that here. R can be between -1 and a +1, meaning on a number line, it can go from 1 to 0 to -1. It can literally be anything between these. So if it's exactly 1, then we say that there is perfect positive correlation, meaning there's a perfectly positive relationship between the two variables. What does perfectly positive mean? It means that both the variables move in the same direction, meaning they increase together and they decrease together. So when x increases, y increases, or when x decreases, y also decreases. So they move in the same direction. So this is perfect positive correlation. Then you have -1. If you get r equal to -1, this means that there's perfect negative correlation. Perfect negative correlation, and all this is in your slides. So you don't have to worry if you're not writing it down or anything. Don't stress about that. It's all in the slides. So perfect negative correlation means that they move in the exact opposite direction to each other, meaning when x increases, y is decreasing, and it's by exactly the same amount. So, for example, if we say x is increasing by 1, that means y is decreasing by 1. They move in the opposite direction and it's exactly the same. Then it could also be that that r is equal to 0. This just means that there is no correlation, meaning there's no relationship between your variables. Then you could also have anywhere between 0 and 1. So on this side, between 0 and 1, this means that it is a positive relationship because the answer will be positive. But if it's closer to 0, it's weak positive. If it's closer to 1, then it's strong positive. So basically, you can use zero point 0.5 as a benchmark here between the two. If it's zero point 0.5 or greater, then it's a strong relationship, a strong positive correlation. If it's less than zero point 0.5, then it's weak positive correlation. So this is weak positive, and that is strong positive. And then it's the same in the opposite direction. If it's closer to 0, it is weak, but it's between 0 and -1, so it's a negative. So this would be a weak negative correlation. And if it's closer to -1, then it's a strong negative correlation. Okay, so this is how you would interpret your answers for R, which is your correlation coefficient, or it's also just known as Pearson's coefficient of correlation. So what is the formula for R? So I'm going to write it at the top. It's actually very similar to the formula for B. The numerator of R is the same exact thing as the formula for B. At the top here, it's n times the sum of xy minus the sum of x times the sum of y. Exactly the same thing. The denominator is also almost exactly the same thing with just one or two changes here and there. So it's firstly a square root in the denominator, and then it says exactly the same as b in the denominator. It says n multiplied by the sum of x squared minus the sum of x squared. And then you're multiplying this by exactly the same thing on the left, but where you saw x, you'll replace it with y. So it would then say n multiplied by the sum. Sorry, it just all went off there. Let me rewrite that. So it's n times the sum of xy minus the sum of x times the sum of y. And then in your denominator, the first part says n times the sum of x squared minus the sum of x, then squared. Close that, multiply by, instead of x, use y. So it says n times the sum of y squared minus the sum of y, then squared. And that is it for the formula. So now let's substitute the values from our question and calculate the value of r. So r is equal to, in your numerator, n is 6 multiplied by the sum of xy, which is 9,600, minus the sum of x, which is 232, times the sum of y, which is 242. Then it's in your denominator, the root of. So the first part says, and again here, make sure you use the brackets correctly. Naturally, your calculators don't have a square bracket. So you'll just use a normal round bracket. But obviously, there is one here on the outside. That's one big bracket. And then you have in the brackets n times the sum of x squared. So n times the sum of x squared is 9314 minus the sum of x, which is the 232, and then that is squared. Then you have, sorry, I think I need to rewrite that one as well. It just keeps shifting for some reason. So once again, n is 6 times the, what is it, 96 minus the sum of x is 232 times the sum of y is 242, and then it's over n multiplied by the sum of x squared, which is 9314, minus the sum of x, which is 232 squared. Close that off, multiply, and now it's n multiplied by the sum of y squared. And now you see that this is so useful, the table where you added on y squared. So it's 9952 minus the sum of y, which is 242 squared. Okay, so once you put this into your calculators, that will give you a value of 0.95. And if you look at how to interpret that, remember they asked you to interpret this. This is firstly a positive value, but it's closer to 1 than -1 or 0. And so this would be strong positive. So you will say that therefore there is strong positive correlation between the variables. Okay, so that is your value of R, and we've also interpreted it by saying that there is a strong positive correlation between the variables. Okay, and then the last question. Any questions on this one, sorry, before we continue? You're all good? Any questions?
All good.
Okay, perfect. Thank you. Yes, a lot of writing, a lot of work, a lot of calculations and additions and so on. But obviously, this part here was just me explaining to you about R. So naturally, you won't need to do that. Also, you won't need to rewrite the formulas because there won't be marks allocated to them. Like the formula of R that I wrote here and the formula of A and B and so on. You won't need to actually write these because the formula sheet will have it. So there won't be marks allocated to writing out the formulas. Okay, so the last calculation we're doing is the coefficient of determination, and then to interpret your answer as well. So the coefficient of determination is a really easy calculation. It's simply r squared. So literally your R value that you just calculated from the previous calculation, 0.95, it's squared and it's a percentage, so you multiply it by 100. So literally take the 0.95, square it, and then times 100, and this will give you 90.25%. So please don't leave it as four decimals or anything and then square it. Literally just take a value for R, two decimals, and then square it and then times 100. And again, your final answer must be in percentage form and also two decimals. So now to interpret this. So this is a standard sort of way that you can interpret it, and I'm going to show you the two ways that you can interpret. So the one way, and what a coefficient of determination tells you, is, remember at the beginning we said that x and y are your dependent and your independent variables. So x is independent, y is dependent, and we know that your y variable depends on what x is. So basically, when x changes, it will bring about a change in y. Now, this coefficient of determination tells you how much of a change in y can be explained by the x variable. So the one way, if you are feeling like you would prefer this method, is to just say that the change in x, which is your x variable, explains, and bring your answer in here, 90.25% of the change in y. So if you're feeling wary, then this is a standard explanation. The only thing that will ever change from this example to the one in that you'll be answering in your assignment or in your exam is the actual percentage. The rest of it stays exactly the same. The wording will stay exactly the same. If you're feeling confident enough, though, you can actually replace X and Y with what they represent in the question. So you could also say that the change in X is the age. So the change in age explains 90.25% of the change in the, what is it, monthly income or annual income? Monthly. So the change in monthly income. So you don't have to do both of them, remember, whichever you are more comfortable with. If you really just want to say that the change in X explains 90.25% of the change in Y, you can do so. But if you're feeling confident enough and you feel like you're okay with it, then you can actually use the values that X and Y represent and say the change in age explains 90.25% of the change in the monthly income. All right. So that's actually it for today and for your linear regression and correlation analysis. Are there any questions from anyone? Anything you're confused about? Laura, I'm assuming you mean when calculating the um, values of A and B. So basically, you would have to do the table in order to calculate A and B. You generally, as I said, 9.99999% of, or 99.999% of the time, they actually say to you in a question, use the table below, complete it, and then calculate the linear regression equation. Almost never. I have personally never seen any of the assignments or tests or exams where they ever didn't ask you to draw up the table first. So you'd need to draw up the table first, use the sums at the bottom to calculate the value of A, calculate the value of B first, then A, and then put together the linear regression formula. All right, so if there are no other questions, then we are done for today. Okay, so
Sorry, I just have one question.
yes, sure.
In the table you added y squared. I know you said it before, but can you please just explain that to me again?
Okay, so the y squared column is not always necessary. And you'll see that in the question they had given to you, they actually stopped here. So y squared wasn't actually asked. It wasn't part of the original table, but I included it because the sum of y squared, this value here, 9952, is used in the formula for r. You'll see here in the formula for r, it says the sum of y squared, and we used it in the value here as well. It was 9952. So that value is included because even though it's not part of the table, if you are asked to calculate the correlation coefficient, then you would have needed that sum. So this is why we calculate that value.
Noted. Thank you.
Perfect. You're welcome. Okay, so any other questions from anyone? We did pretty well for time today. So hopefully you will have no problems with any of your next lectures. I am going to stop the recording.